4 semester skill enhancement course degree examination July-August 2024 computer science artificial intelligence. ಇದು ಟೋಟಲ್ 30 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಪೇಪರು. ಸೆಕ್ಷನ್ ಎ ಮತ್ತು ಸೆಕ್ಷನ್ ಬಿ ಇರುತ್ತೆ. ಸೆಕ್ಷನ್ ಎ ಅಲ್ಲೆಲ್ಲ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸು. ಎನಿ 5 ಕ್ವಶನ್ಸ್ ಅಟೆಂಡ್ ಮಾಡಬೇಕು. 10 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ ಸೆಕ್ಷನ್ ಎ ಇಂದ. ವಾಟ್ ಈಸ್ ಪವರ್ ಬಿ ಐ? Power BI is a business analytics service by Microsoft that allows users to visualize and share insights from their data. Define natural language processing. Natural language processing (NLP) is a branch of artificial intelligence that enables computers to comprehend, generate, and manipulate human language. Define Neptune. Neptune is a lightweight experiment trackers for ML teams that struggle with debugging and reproducing experiments, sharing results, and mesh model handover. Define deep learning. Deep learning is a method in artificial intelligence that teaches computers to process data in a way that is inspired by human brain. Deep learning models recognize complex patterns in pictures, text, sounds, and other data to produce accurate insights and predictions. What is diagnostic analytics? Diagnostic analytics examines data to understand the root cause of events, behavior, and outcomes. Data analytics use diverse techniques and tools to identify patterns, trends, and connections to explain why certain events occurred. Write the steps to upload your Excel file to the Power BI. In Power BI, click Get Data in lower left screen. Under Import or Connect to Data Files, click Local Files, choose which file to upload and click Open. What is data connection? Data connection is a network of connection that can send or receive information. What is machine learning? Machine learning is a field of study in artificial intelligence concerned with the development and study of statistical algorithms that can learn from data and generalize to unseen data and thus perform tasks without explicit instructions. Next section B ಎಲ್ಲ 5 marks questions. Any 4 questions attend ಮಾಡಬೇಕು. First one, explain machine learning and its types. Machine learning ML is a discipline of artificial intelligence AI that provides machines with the ability to automatically learn from data and past experiences while identifying patterns to make predictions with minimal human interventions. Types of machine learning: supervised learning, unsupervised learning, reinforcement learning. Supervised learning meaning: supervised learning is a type of machine learning where the algorithm is trained on a labeled dataset, meaning that each training example is paired with an output label. The goal is to learn a mapping from input to outputs so that the model can predict the output for new unseen data. Supervised learning is widely used due to its effectiveness in many real-world applications. Applications of supervised learning: image classification, identifying object faces or scenes in images; spam detection, classifying emails as spam and not spam; sentiment analysis, determining the sentiment positive, negative, neutral of text data; speech recognition, converting spoken language into text; medical diagnosis, predicting diseases or conditions from patient data; fraud detection, identifying fraudulent transactions or activities; recommender system, predicting users' preferences for products or services. Unsupervised learning. Unsupervised learning is a type of machine learning where algorithms are used to analyze and model data without labeled outputs or supervision. The main object is to uncover hidden patterns, structures, or relationships in data. Unlike supervised learning, which relies on labeled data to train models, unsupervised learning deals with the data that has no pre-existing labels, making it useful for exploratory data analysis, dimensionality reduction, clustering, and more. Applications of unsupervised learning: customer segmentation, identify distinct group of customers based on purchasing behavior, demographics, or other characteristics for targeted marketing. Anomaly detection, detecting fraud, network security threats, or rare medical conditions by identifying de- deviations from normal patterns. Market basket analysis, discovering associations between products purchased together, useful in retail for recommendation system. Document clustering, organizing a large data of documents into meaningful clusters, aiding in information retrieval and topic discovery. Image impression, reducing the size of image files using techniques like Attonian coders without significant loss of quality. GNA experience express analysis, identifying patterns in a GNA expression data useful in bioinformatics and medical research. Next to reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by taking actions in an environment to maximize cumulative rewards. Unlike supervised learning, which relies on labeled data, enforcement learning involves learning from the consequences of the actions using trial and error to discover the best strategies. Key concepts in reinforcement learning: agent, the learner or decision maker; environment, the external system with which the agent interacts; state, a representation of the current situation of the environment; action, a set of all possible moves the agent can make. Reward, feedback from the environment based on action taken. Policy, the strategy that the agent employs to determine actions based on the current state. Value function, estimate the expected cumulative reward of being in a given state or state action pair. Next question, explain the tools for machine learning experiments visualization. First one, Neptune. Neptune is a metadata store for MLPs built for teams that run a lot of experiments. It gives you a single place to log, store, display, organize, compare, and query all your model building methods. Neptune is used for experiment tracking, model registry, monitoring ML run lives. Weights and biases. Weights and biases is a multiple learning platform for developers to build better models faster. It lets you quickly track experiments, version, and treat on datasets, evaluate model performance, reproduce model, visualize results, and spot regression, and share finding with colleagues. Comet. Comet is a meta machine learning platform for tracking, comparing, explaining, and optimizing experiments and model. It also lets you monitor, detect, and alert and debug production models in real time. You can also build your own or use community provided custom visualization and applications based on experiments and model data. TensorBoard. TensorBoard provides the visualization and tooling needed for machine learning experimentation. It open source and offer a suite of tools for visualization and debugging of machine learning models. TensorBoard is most popular solution on the market, thus it's widely integrated with the many other tools and applications. MLflow. MLflow is an open source platform for managing the end-to-end machine learning lifecycle. It is currently by far the most widely used ML experiment trackers, and as such as is widely supported by the language frameworks and platforms. ML supports logging through Python, R, Java, and REST APIs. Next question, explain the core components of analytics. Data collection, gathering relevant data for various sources which could be structured or unstructured. Data storage, storing data in a structured manner, often in database or data warehouse to facilitate easy access and retrieval. Data processing, cleaning, transforming, and preparing data for analysis to ensure its quality and relevance. Data analysis, applying statistical and computational techniques to explore, understand, and derive insights from Data. Data visualization. Presenting data in visual formats such as charts, graphs, and dashboards to facilitate understanding and decision making. Data interpretation. Making sense of analyzed data to extract meaningful insights and actionable conclusions. Decision making. Using insights gained from analytics to make informed decisions that can optimize processes, improve performance, or solve business problems. Data governance and security. Ensuring that data is handled responsibly, securely, and in compliance with regulations and organizational policies throughout the analytics process. Explain map visualizations. Map making or cartography is the visualization of geos practical data. It's an art of that it seeks to represent data in the form that can be more easily understood and interpreted by an non-technical audiences. Advantages: decision making, identifying trends faster, improves retention and engagement, data accuracy, communication, navigation. Map visualization are graphical representation of data that graphically referenced. They display data points or strategical information on map, providing spatial context and allowing user to explore relationships and patterns across different locations. Map visualizations are particularly useful for spatial analysis, data exploration, decision making. Explain natural language processing (NLP). Natural language processing (NLP) is a subfield of artificial intelligence that focuses on the interaction between computers and human languages. It involves the development of algorithms and models that enable machines to understand, interpret, and generate human languages in a way that is both meaningful and useful. Here, an overview of key aspects and applications of NLP in AI. Key components of NLP. Tokenization. Breaking down text into smaller units such as words or sentences. Part of speech tagging, POS tagging, identifying the grammatical parts of speech, nouns, verbs, adjectives for each word in sentence. Named entity recognition, identifying and classifying proper nouns in text such as name, people, organization, location, etc. Parsing, analyzing grammatical structure of sentences. Sentiment analysis, determining the sentiment or emotional tone text such as positive, negative, or neutral. Mission translation, automatically translating the text from one language to another. Text summarization, producing a concise summary of a longer text document. Speech recognition, converting spoken language into text. Language generation, creating text that is coherent and contextually relevant. Last one, explain visualize data in Power BI. With the technological revolution, data went into expensive, difficult to find and collect, to abundant, cheap, but incomprehensibly. It is arduous to store, understand, analyze increasingly larger volumes of data with traditional softwares. However, as individuals or an organization, all of this data is only as good as what we can make out of it. This is where big data comes into play. Big data is used for predictive analytics, analyzing user behavior or other data analytics processes to bring value to data. Yes, the raw material support this can remain uncertain due to lack of knowledge. Data visualization helps to tackle this issue. Data visualization is a process of transforming data into charts, images, graphs, and even videos that explain the number and allow us to gain insight from it. It makes information more coherent and helps us create value out of it, discover new patterns, and spot trends.